So before we start, I thought we'd go over the questions that Dror had raised on the PR that was merged last week. Uh, I think the first one, Dror, was on the format. I mean, to choose whether JSON or YAML.
Yes.
As I explained in that, my understanding was I chose JSON because if in case the bundler implementers wanted to verify the file from IPFS to receive which chain ID or what it represents, a JSON format would be more suitable for it. But I understand where you're coming from on YAML because it's going to be mostly used by the DevOps team. So I thought we'd come on and I mean, all of us have to come on the same page, which way we want to go forward. But more than the format, it's more to do with what details we wish to put in there. Are we happy with the stuff? I mean, the fields that I've listed there, is there anything that we need to add or remove? I'd be happy to do.
Again, I'm saying this file is non-normative. It could be that some bundler will find out that they need to change the code of the bundler, and they say, must use patch XYZ because we are doing something differently. It cannot be I started to write a comment that I think that it shouldn't be formatted at all. It should be only clear text. Now, that's a bit too extreme, because I agree that there are fields like chain ID and maybe entry point that might be useful to have. So YAML is going in between. It can be free text. We are not formatting it in any way. Yes, in a non-normative way, we'll write entry point colon so that you can read the entry point from that file, but I'm not trying to formalize it more than that. It is YAML, and yes, it should signify the chain. And then, for example, it is possible to have a single file saying that this is the standard for network A, B, and C in text. Because you cannot, I'm not saying there is a field which specify a list of chain IDs. No, the text might specify it. But so again, YAML is good enough, and we have an example, and it should specify, again, it's a level of should, entry point and chain ID. And entry point, chain ID, and stake. These things we know that must be decided, but no more than that.
Okay, so I'll probably then change that from JSON to YAML with just a, I mean, a suggestion on what the fields are nice to have, but we let the implementers decide whichever way they want.
Yes, they probably will push a file that is good enough for the main chain, and when we find out we need to do some changes, we'll push another one, and probably people will copy it and write the changes they want.
Okay.
So it's okay.
Sounds good. So yeah, I'll go ahead and make that change.
Yeah, I think there is a benefit in partially standardizing it so that you can always read the entry point and the chain ID from it.
Yeah, it is nice.
The rest is free text, but if, for example, we said that it always starts, it's a YAML that always starts with the entry point and chain ID, for example, this could be useful for making some parsing possible. But the rest is free text that could describe patches or anything.
Okay, noted. The other one, I believe, was Dror's question on, I mean, on what was the need for the request response of user ops being sent through. I mean, I did explain that my understanding there was as soon as a bundler started, it could request for a given user op based on a hash, because I believe in Gossip Sub, even though you're not subscribing to a particular topic ID, the nodes that are part of the network can gossip or just let the other peers know what message they've seen on a given topic. So in such a way, if one of the nodes in the connected network have not received a particular user operation hash, they can request for it from one of the connected nodes to their peer, to be added to their local pair.
How do they know the hash?
This is what we. I mean, that should be probably another topic that we publish in terms of user operation hashes.
No, the way you receive a hash is that you know of a user op, and then you hash it, and you know the
Correct.
hash.
Correct.
So it means there is no point where you have a hash and you don't know the user op. We are not communicating the hashes in any way. We're communicating user ops.
Yeah.
So how would you come with a hash and ask for user op?
Yeah. I'm proposing we have another published message along with user op with entry point with just a list of hashes that a particular bundler has received at any point in time. So you'd have two gossip subtopics. One is a user op with entry point. The other is a list of user op hashes that a given bundler has received at probably a given interval. I mean,
I'm not sure how normal nodes communicate with each other regarding transactions. Is there an equivalent to ask for a transaction based on
not necessarily on the transaction? I'm referring more on the beacon chain. If you see on the beacon chain, you've got a beacon blocks, signed beacon block hashes, which gets propagated along with a given, what do you say, a given beacon block. And those blocks that have been missed can be requested for using the hash in the request response.
Why would you miss it? Because
if you're okay, so
no, okay, go ahead.
No, what I'm trying to say is, you've just started off a node. This is we don't at the moment we are not proposing each node that is part of the bundler network holds a state of what is the last user operation it's received. But in the case of consensus network, we maintain the block height, right? The beacon block height. So we will know whether a given peer is in sync or is still not synced up to the current level, current height. So if a given block is still catching up, if a given node is still catching up, it can request for the historical blocks from the connected peers based on a given block hash.
Look, I'm trying to think of it this way. We are creating a mempool of transactions.
Yep.
The user project is a transaction. So if we see the way an execution layer mempool works and it has some limitation and something that we can improve because the model they use is not efficient enough, like we use dev P2P instead of lib P2P. Okay, because it's a newer library, it's okay, it's great, it is proven, so there's no problem not to use it. But I'm trying to understand what is the problem in the execution layer mempool, because we are building a mempool, that a deficiency in the current system that we need to use a different mechanism.
No, I'm not saying we're using a different mechanism. We are using the same thing that's already there in transaction mempool, because in transaction in dev P2P execution layer 2, whenever a new transaction enters the mempool, the transaction hash gets propagated to all connected peers. So I'm trying to replicate the same thing here as well.
Okay. What you're saying is that there is a mechanism to propagate this.
It is, yeah.
Okay. That's what I was asking, and I didn't get a clear answer. Okay. Actually, this is something I didn't look. What are the messages that a normal mempool has to propagate through the pub sub channel?
Yeah.
We should have probably the same, unless there are methods that are not in use.
Yeah. The other scenario I was thinking of is, say, assuming two bundler nodes start up, and what is the way they will know that they are up to date on the user op mempool? Because if either of these nodes do not propagate any user op between them, but the heartbeat is always successful, then there is no way in the current setup for us to determine if a connected peer is actually behaving properly, because we expect every connected node to propagate a user op it receives to all the connected peers. Otherwise, you would have to descore the connected peer and probably try connecting to another person. In the current setup, we don't have any such mechanism to determine if a connected peer is behaving properly. Do you see what I mean?
So okay,
I
yes,
could have
okay.
a selfish
So
peer.
okay. So what you're saying is that I'm trying to understand the flow. A node starts up. So in order to know all the needed user op, the way I thought is that you connect to one of your peers and you ask all user ops it has in the mempool. Hello, can you hear me?
I can hear you.
I can hear you.
No, I saw Prasanta removing his headset and some maybe network error because can you hear us? Okay. Okay.
Your video seems choppy, so maybe.
Okay, yes, but if he's hearing us, then it's okay. So a bootstrap means that I need to, in order to get in sync with the network, I connect to the peer, at least one of them, and request the entire mempool. Not hashes, I will request the entire mempool. Now, once I get it, I think that I'm in sync. What I'm not sure is that should I connect to other peers and ask them also for the entire mempool or ask them only for the hashes? I'm trying to understand the flow actually. I don't know what is the existing flow.
Okay, my question is, you are a node that has just come up, a bundler node that's just come up. Your local mempool is empty. So who among your peers are you going to request for the user op? You would, I mean, in the current consensus layer setup or on the execution layer setup, you request a subset of the connected peers for the transaction mempools, right? In our case, if we decide to do so, then that means we are requesting for the entire mempool to be sent over to us. So that's a new request response topic that we'd have to add. But what if we don't get any response from any of the connected peers? How do we validate whether the connected nodes are intentionally not sending us any data, or there is actually been no user operations that have come through in that given time period? So, I mean, programmatically, a node would not be able to determine whether the connected peer is, honest or not.
Okay, so what is the mechanism in execution layer right now?
This is a question I don't know. I was wondering, how do we solve this scenario? One thing that I could think of was for each bundler node to periodically test the entry point contract of the canonical mempool to see if there were any new user operations submitted in a given time span, and the node has not received those user operations as a part of its peer-to-peer from its peers. If so, then we could probably, the node can give a negative ranking to its connected peers and try connecting to another set of peers. This is something I thought of. I don't know. I wanted to run this down with you guys to see if are you in agreement, or can you think of anything, any better way to do so?
I don't think the execution layer has anything like that.
Yeah, I'm sorry. I think it's the consensus that does it. But in consensus, you're right. You can validate based on the beacon block height. But given that we don't store a state as such for each bundler node, this was the only thing that I could think of.
Yeah, we know.
You see what I mean?
We know. Yes, but actually, even if you see transaction on chain.
Yeah, it's hard to tell if
it doesn't mean that it didn't come through, say, a private mempool. You cannot tell whether they are.
I mean, at least on the consensus node, you would know whether the connected peer is on the same blockhead as yourself. Then you would know that you both are in sync. But here, as we don't store a local state, there is no easy way for us to validate whether the connected node is incorrectly implemented or is not behaving honestly. That's what I'm trying to get at. I mean, you understand the scenario, right? You are connected to 10 different peers.
I understand. No, and again, I always try to fall back and say, how is the execution layer behaves? What is the logic of the execution layer mempool right now? And let's see if we can reuse or at least replicate it. I don't want to be smarter than the execution layer. At next phase, we can do it. We can add such a, what you suggested is a very interesting mechanism. It's a way for you to find out that you are being censored by your peers.
Yeah.
And you are now seeing part of the mempool. But before we go that path, let's start with assuming they don't try to block you, and first find a way.
I mean, the only other thing I can think of is probably we store the block height for the network that we support, and we see as a part of the heartbeat, we check from our peers what block height they are at. If all of us are in sync, then we continue to remain connected to that peer.
I feel like this isn't something that needs to be part of a specification and can be something that's just an optimization that individual bundlers make, and just in terms of this deciding whether or not they have a good peer is more of just like a local decision versus a network decision.
As a worst case, increase the number of your peers. Ask all of them. Connect to all peers you can find and consolidate the entire list. This way, any specific one trying to censor you, you will still get the information. Anything else, like connecting to a smaller set, is an optimization.
No, I'm not saying connecting to a smaller set. I'm just trying to validate if the connected peer is behaving honestly.
Again, I don't care. I'm doing a superset. I'll connect to everyone.
Okay.
And if I connected to everyone, then I don't care if someone doesn't send for any reason some of the user ops to me, I don't care because I get him through other channels.
So what is the ideal number then you would suggest?
I don't say, no, I don't, I refuse to decide on a number, except for copying it from you're raising a problem. I'm saying, I have a solution. It's not optimal. So everyone will try to find a solution. And after we have a network, we'll optimize it. I don't want to do it before we have a network.
Okay, as a part of the consensus spec, they define the minimum connected peers that's set up as a part of the preset. I'm pretty sure we are not going to expect the same level of connected peers in the bundler network when we start off. But we need to specify certain minimum number as a part of the spec. Otherwise, I don't know. Just as a suggestion, not necessarily mandatory values, right?
I think Get, I think they do 25. So that might be a good place to start.
What, 25 connected peers?
Yeah, so by default, the connected peers are at 25.
Okay.
Okay.
It's nice, but I'm not sure we will start with so many bundlers. So basically, you are saying that we are starting with a full mesh.
Yeah, that would be nice, but yeah, I don't think that's going to be the case either.
No, if we have 10 or 20 bundlers, then a full mesh might be good enough. I don't know.
Okay. I mean, or we could set an optimum level would be 10, but it need not necessarily meet that criteria. But you should actively try to connect at least to 10 peers as, I don't know, to be sure that you're not missing out any user ops.
To me, that just sounds like something that a bundler can make their own decision on. That doesn't need to be spec'd.
Yeah,
okay.
I don't think it's really spec'd for it's not really spec'd for the regular mempool, right?
I don't know. I'm not sure if it's done on the execution layer, but on the consensus layer, there's definitely a minimum value set as a part of the spec itself.
We are an execution layer.
Sorry?
We are an execution layer. We are not
Yeah, but we are following libp2p, not devp2p, right? So our thing should be in line with what libp2p expects.
Yeah, even in the consensus layer, you can configure it per validator. I remember that in the early days of the consensus chain, the minimum number was lower, and I actually had to increase it in my validators in order to because otherwise it didn't function well. So sometimes I missed attestations until I increased the number.
Okay.
What does it mean to miss attestations?
In the consensus layer, it means that I publish an attestation, but it doesn't get propagated in time. So so I needed to. I remember I needed to increase it to increase the number quite a bit in order for it to be reliable.
Okay.
So my point is that it's configurable, even if it's in the specs. You can still configure it in the validator.
Okay.
Yeah, you can maybe recommend a minimum, but apart from
Yeah.
that, yeah,
I think that's how it works for the consensus layer.
Okay. So yeah, for now, when we start off, we give a minimum number as the recommended value, and then change it as we seem fit based on the number of nodes that turn up.
yeah, I think that makes sense.
Yeah. So then we are in sync that we don't need to, these bundlers don't need to maintain a local state. We just ensure that we validate whether the connected peers are valid, however each bundler implementation wishes to do so. But we are not trying to replicate the local state based on storing the last connected block or whatever. Cool. Yeah, the other question I had was what, I mean, how long can a given user op reside in your local mempool? The reason I ask is certain bundlers might not find a given user op to be profitable to be included as a part of their bundling operation. In the current transaction mempool, transaction remain in pool for up to 100 blocks, or after that they get discarded. Are we proposing something similar for the user op mempool?
I think, we specified something like 10, didn't we?
I didn't quite get what number are we talking about?
So let's say a user op comes in with a very low gas fee and it doesn't get included into the block because none of the bundlers find it to be a profitable transaction. So how long we wish to keep this in the mempool?
Yeah, is it defined for the execution layer? Because in the execution layer, you can propagate a transaction with a very low gas fee. And if you look at Etherscan, you can see it. I mean, sometimes it disappears, but sometimes I see it even weeks later. So I assume it's not really spec'd out, right?
Yes, but on some networks, I remember that when sending a transaction with very low gas fees, the node just simply rejects it.
Yeah.
So
for a node, it makes sense to have a maximum amount of a maximum number to store. So then and then you start dropping, you start evicting the ones that pay the lowest fee. So
not only start evicting, I'm talking about when sending the transaction. Some nodes will simply,
if someone sends you something that you are very unlikely to include anytime soon, there's no point in even simulating it. You can just ignore it.
Yeah, so the point is that in our case, there are also transactions that got invalidated. Because if you are a bundler and you revalidate, you can drop it. But all those access node bundlers, which only do the initial validation, those transactions that fail the second validation will wait this entire time in their mempool because they will never know when to invalidate them. Of course, unless they get replaced by a higher fee or something like that. But otherwise, they will stay until this block timeout.
Yeah, that's anything that gets invalidated. Only those who simulated it know that it's invalid and can drop it. So any bundler that holds it in the mempool but never simulates it a second time has no criteria for dropping it other than waiting a certain time.
So what is that certain time? Are we looking to define that, or it's open to implementers to decide how long they wish to?
I think it's fine for the implementer because I mean, someone with limited resources would keep the number low in order not to waste storage for it. But someone with more resources could be more profitable by keeping these. Maybe people submitted it in the middle of the week, and it will become it will make sense to include them in the weekend. But then in the weekend, maybe you won't get them. So so maybe you want to store them and get back to them when the gas price is low.
Okay.
So it's really up to the bundler to decide on strategy. And overall, I don't think we should mandate internal things for each bundler, because each bundler could have its own strategies and be competitive in its own way. So we should only mandate things that affect the mempool.
All right. Okay. Yeah, these were the only questions I had. Is there, I mean, so are we all happy with the spec that we have in place? Is there any other questions that anyone had in that?
Sorry if I missed it, but did we come to a conclusion on whether or not we wanted to be propagating hashes around and adding request response for user operations? Just like, so the execution layer mempool, and this is different because it's dev P2P and it doesn't have the same lib P2P gossip protocol already laid out for it, but it does have the endpoint for when a node comes online, they connect to a peer, they say, hey, send me all of the hashes that you have, and then they diff the hashes between different peers that they don't know about, and then they request for specific full transactions from those peers as part of bootstrapping the initial loading of their mempool. Does libp2p gossip handle that, or do we have to do that, or do we not want to add that sort of functionality? I'm not super versed on libp2p, so I'm curious if what we think about kind of bootstrapping the mempool, and then also just the fact that we're not propagating hashes.
The hashes are kind of optimization. Like, I contact like all the bundlers and ask for all the hashes for each one, and I use it in order to assure myself that I got the actual user operation from the 2 or 3 I asked for the entire mempool. But again, it's an optimization mechanism, and I wonder if this is the best way to do it.
What's the way the execution layer does it?
That's the way to do. You ask for hashes for everyone, and then okay.
I believe you don't ask. It's like when you connect to
it's by default. As soon as you're connected, yeah,
they just send all their hashes over up to like 4096 hashes, I believe.
Right. I think that's not implemented in the traditional libp2p gossip protocol. We actually got rid of the request response pair, so I think we might have to add that again just for the bootstrapping.
Yeah, I'll be including that when I submit a PR after this call. I'll include the list of hashes as one of the request response topics.
Okay. So I'm curious how that interacts with the gossip topic, because in dev P2P there's only that mechanism. So it's just like they tell it that you just propagate to everyone your hashes when you're connected to them, and then also as you get new hashes, and then they just request for the transactions themselves. Are we just going to use that request response for bootstrapping and then gossip for once you're bootstrapped?
Yeah, I think that's better. Otherwise, we might end up having 2 separate global topics that each nodes have to subscribe to under Gossip Sub. At the moment, there is one topic, which is user op with hash. If you wish to propagate a list of user op hashes as well as a part of the bootstrap, then there would be 2 separate global topics. Rather, we have it as a part of the request response. As soon as a connection is made to a peer, you request the list of user ops via request response, and then you can validate whether it's already a part of your mempool or not.
Makes sense.
Yeah. So yeah, those were the two points that I've made note of. Anything else that you would like to discuss, or what's the next course of action you'd propose?
For me,
Dror
everything
and-
was clear.
Sorry, Jonas, I didn't catch that.
For me, everything was clear. Yeah, the request response thing is important, and I think I thought that would happen under the hood, but indeed for mempool bootstrapping, that's definitely something that we need to add.
Yeah.
Okay.
What we're missing is the flows. The first flow is initial flow. How do I bootstrap? Then action to be done when you receive a new user operation, either through RPC or from another node. Are there any other flows? There's no periodic check or something.
Sorry, what was that?
There are no periodic checks, right? You don't do sanity check periodically, like requesting all hashes from all bundle to make sure that you are still in sync.
I mean, at the moment, we just have a heartbeat as a part of libp2p that just checks whether you get a valid response within a given time frame from each of the connected peer nodes, and then you assume that the connection is active then. But if you wish to add additional validation, then we can probably do that.
I don't. Again, I'm trying to think.
Yeah, I see what you mean.
Protocol, so maybe we don't need it. Maybe these are all the flows we need, and we don't need anything else.
Okay. How do we proceed with the test suite for the peer-to-peer protocol? Are we looking to define this as a part of the existing test suites, or?
So this would be something like Hive, right?
Yes, it's. We looked briefly into Hive, but since our tests are more applicative, we did use it for the basic flows of the spec test. Regarding of this test, we look at it again whether it is better to use Hive or this support to our framework.
Okay.
Dror, wouldn't it make sense to add it to the current tests? Not because with Hive you try to use you can use multiple clients, but here we already take one bundler and run a series of tests on it. So we could also test the protocol, send it various messages and check its behavior.
The actual test to be done is not that each bundler runs to the spec, which is important. Yes, this is something, but actually bringing twins, bring instance of A, instance of B, ask A something and see the response, and bring up all the combinations. Because
interoperability. Yes, for interoperability tests, it's that's something like Hive. But I was wondering if we shouldn't also add to the current tests something that makes sure that each client, that each bundler uses the protocol correctly.
The point is that in order to, since it's a complex protocol, it's not an RPC that I can check from the test into the bundler. I need some client to use this RPC. So the way I would think the client, the node that will bring up this RPC call will be the reference bundler. So actually, the check will be, tell the reference bundler do something. It will connect to the other node and see that they can talk with each other. Because when it comes to using an API, you need a code to run this API. It's not something you can just read the JSON files and see that it works. So we defined in the spec how the API should be used, not the actual messages that go through, because this is the way libp2p is working. And a single test will be bring up the spec test against another server. Now, this is not enough. It's a good start, but it's not enough because even the reference server will have its own quirks. So, but once we have a test that can bring server A, server B, and interaction between them, I can put any server A with any server B and check all the combinations.
Or
So yes, it would be a script that brings two.
Let's say at the moment we have 5 different bundler implementations live. Then we can bring an instance of each type, set up a network amongst these 5, and see if the data gets propagated to all of the connected peers.
Not all. It's I check if each two. I bring up 2 instances and I send message to one.
Okay.
I see it go to the other, and I see that this one is good. To the flow. One of them is that you can get entire bundle when you are bootstrapped, and the other is that a single or sequence of messages can get through. Yes, they're gonna be a full test, but again, with Hive, you need to write down the JSONs that of the actual messages that go through. Yes, it is possible, but I think again, to put it, you have to put it into the test. It means we need to use the Python library in order to test all the bundlers.
Yeah,
and the tests.
That's going to be interesting. I mean,
Yeah.
At Etherspot, we released, we open sourced our bundler implementation today. So, and I'm also working on the POC for the P2P right now. I'll share that as soon as it's available.
Okay, good. Your bundler is in Go?
TypeScript. It's in TypeScript.
Your TypeScript.
Yeah.
And it's going to easy. Okay, it's easier for us to input the code. No, but actually that's not good, because we can copy quirks and bugs just along. It's better to do it cross language.
So that brings me. There was another RPC endpoint that I had requested earlier. I think we were discussing this in the Telegram group. The list of supported mempools a given bundler should support. We have an entry point for. I mean, we have an endpoint for the entry point contracts, but we don't ask for the supported mempools as such. Can we include that as well as a debug endpoint?
To ask what for the supported mempools?
Yeah,
I think it's possible. We can ask for the publicly supported mempools.
Can that be added to the RPC spec? I mean, under debug?
Yes, I believe we can add it.
Okay. So I'll probably submit a PR for that with this one and send it to you both, to you all for review, and please include that. I think I'm done with the list of questions I had. Does anybody else have any questions?
No.
No, I think we're good now.
All right. So are we meeting on March 6th then, which I believe is the next Thursday, right?
March 6th, I believe we're still in Denver.
Yeah, we are traveling.
Okay, so I'll probably cancel that call and we'll meet in 4 weeks then, or do you want to reschedule immediately after that, in March, the week beginning March 9th, I believe?
To shift by a week.
I think if we shift it by a week, it's going to coincide with the other call, right?
Oh yeah, the core devs call. So, yeah.
2 weeks from today is March. 2 weeks from today is March 9th.
Oh yeah, sorry, my bad. March 9th.
I think it's okay, March 9th.
Yeah, I think
Dror
will be back.
Yoav, when is the conference over? When are you coming back?
So I'm coming back a few days after Dror. So I think Dror will be back on the 9th, but I'm actually flying back on that day. So I will be I'll be on a long flight at that time on the 9th.
Okay. So you're all are happy to have the call, or should we cancel it? And
I think it's fine if you have it without me.
Okay. Okay, we'll miss you, but we'll manage.
I'll check the time. If I can join from an airport or something, that would be also okay.
Okay.
discussing P2P from an airport, that's going to be interesting.
Yeah.
All right. If nobody else has anything, then I think, yeah, thanks everyone, and see you again in 2 weeks.
Okay.
Thank you.
Just
Okay.
have a
Bye.
nice time at Denver. Sorry, I'm going to
Bye.
miss it, but yeah, have a nice time, everyone.
Bye.
Bye.